All right, let's dive right into this explainer and tackle the ultimate Bombardier Q400 approach dilemma. What exactly do you do when your weather report is missing the runway visual range? Look, if you're operating the Q400 and the weather is rapidly closing in, knowing how to handle your minima is absolutely non-negotiable. So today, we're breaking down the official guidelines to make sure you know exactly when and how you can legally continue that approach.
Here's our exact flight plan for this explainer. 1. The missing RVR problem. 2. Deriving RVR to CMV. 3. The visibility conversion table. 4. The TVRD8 exceptions. And 5. The required lighting prerequisites. Let's get to it.
Section 1. The missing RVR problem, when meteorological visibility is reported, but RVR is not.
Picture this. You're up in the flight deck of a Q400, prepping for your approach. You grab your weather briefing, you see your reported meteorological visibility, but there's a glaring omission. The RVR is completely missing. Now, the immediate question every pilot faces here is simple, but absolutely critical. Can you legally land this aircraft? Well, before we make a move or even think about touching a calculator, we have to consult our ultimate source of truth, which is the DGCA CAR Section 8, Series C, Part 1 on all weather operations. And the good news? Under these exact regulations, you don't have to just throw in the towel and divert immediately. There is actually a sanctioned legal procedure to figure this out.
Moving right along to Section 2, deriving RVR to CMV, the mathematical solution.
So, the crucial piece of the puzzle here is understanding what CMV actually is. It stands for Converted Meteorological Visibility. When that RVR isn't reported, the regs say you can derive the CMVs straight from the reported visibility. It's a value that the book considers perfectly equivalent to a runway visual range, and this equivalent value is exactly what legally allows us to commence or continue our approach all the way down to our applicable DA or MDA. Think of it as a literal mathematical bridge from your weather report directly to your approach minimums.
Section 3. The visibility conversion table, multiplying visibility by day, night, and lighting. Now, to actually derive this CMV, you just have to look out the Q400 cockpit window, check the time of day, and look at your lighting. And I'm going to give you the plus 0.5 trick to memorize this effortlessly, even in a super high workload environment. Here's how it works. You start with a base multiplier of 1 for any basic lighting during the day. Then, you just add 0.5 if it's night, and you add another 0.5 if you have high-intensity runway lights plus an approach lighting system, okay? So basic lighting during the day is 1. Basic lighting at night, 1.5. HIRL plus ALS during the day is also 1.5. And the absolute best setup, HIRL plus ALS at night, gets you a multiplier of 2. Seriously, just remember that plus 0.5 rule for night and better lights, and you're golden. This slide brilliantly shows us the two extremes of that table. Over on the left, we've got our best case scenario. If it's night and you've got HIRL plus ALS up and running, boom, your multiplier is 2. You literally double your reported visibility to get your CMV. That's a huge advantage. But look over at the right side, the worst case scenario. No lighting at night. The multiplier there is just NA. And here's a great little memory aid for you. If there are no lights at night, landing is not around, right? Because of that NA. In that specific scenario, you absolutely cannot do the conversion. Period.
Okay, Section 4, the TVRD8 exceptions, strict safety boundaries where CMV is forbidden.
We've got the math down, but before we go applying it willy-nilly, we gotta hit the brakes. There are strict exceptions where this conversion is absolutely forbidden, and you can flawlessly memorize them using the TVRD8 trick. Ready? T is for takeoff. V is for visual or circling approaches. R means the RVR reported is actually available, meaning if you have it, you use it, you don't calculate it. D is for dispatch, and 8 stands for 800 meters. TVRD8. Lock that acronym in your brain, and you will navigate the DGCA CAR restrictions like a pro.
Let's actually zero in on that last rule for a second. 800 meters. You absolutely cannot use this mathematical conversion to calculate any required RVR minimum that is less than 800 meters. So if the minimum required RVR for your specific approach is, let's say, 600 meters, no way. You cannot use CMV to get there. This math is legally valid only for approaches that require an RVR of 800 meters or more. You know, it's incredibly telling that the source material literally repeats this exact not used for list twice. They are really hammering home just how critical these safety boundaries are. In the official all-weather operations document, that block of important notes covering takeoff, visual approaches, dispatch, and the 800-meter limit is printed and then printed again immediately after. Look, when the regulators say something twice, they want it permanently etched into your brain. TVRD8 is your safety shield here.
And finally, Section 5, Required Lighting Prerequisites, the final operational checks.
You can't just blindly trust an approach chart. You must verify that the installed lighting facilities you're relying on for your math are actually available and in operation. Notice how the conversion table specifically said lighting elements in operation. So if a NOTAM pops up saying the approach lights are out of service, guess what? They aren't available, and you cannot use that HIRL plus ALS multiplier. You have to downgrade your math to reflect the actual reality on the ground.
Visually contrast this with our previous number. We just talked about 800 meters as the minimum calculated RVR allowed, right? But here is another vital number you need to know: 420 meters. 420 meters is the absolute minimum length of approach lighting required to even apply the CMV. If that approach lighting system is shorter than 420 meters, you just don't have the legal prerequisite to use the mathematical conversion at all.
So let's put this whole puzzle together. If your Q400 is being considered for dispatch at night and there are absolutely no approach lights, what's your move? Do you attempt the math or do you divert? Think back to our TVRD trick. D stands for dispatch, remember? And what did night with no lighting equal on our table? Keep that plus 0.5 trick and the TVRD8 exceptions right there in your mental flight bag, and think about what your final call would be in that scenario. Thanks for joining me on this explainer, and safe flying out there.